Assalamualaikum.
Waalaikumsalam. Selamat siang, Bapak Dr. Muhammad Azrin.
Selamat siang. Salam Bapak Wikaria. Sihat ya?
Ya. Wikaria. Apa kabar Pak
Sihat.
Muhammad Azrin?
Sihat. Saya sihat saja di sini.
Sama kita ya.
Bapak, boleh kita teruskan?
Ini akan dibuka oleh halo Ibu Ajeng. Ibu Ajeng.
Halo Pak Wikaria. Halo Dr. Azrin.
Hai.
We can start now. You can share screen. I already make you as a co-host.
So I should start my lecture straight away?
It's okay. Okay. Good afternoon, all the participants and all our lecturers. Thank you for being here. Thank you, Dr. Azrin, for being our speakers for today with the topics double integral. So I will let's see. Okay, okay. Dr. Azrin, you can start the presentation now.
All right. Thank you so much, Ibu Ajeng daripada BINUS saya rasa. And then thank you so much, my counterpart from BINUS, Associate Professor Wikaria Ghazali. All right, so I will start my presentation. So basically, I will stop sharing the video because I'm using my iPad. So I'm going to write something during the presentation. Wait for a while, yeah. Right. So first and foremost, can each and every one of you see my screen clearly?
Yes.
Right.
Dr. Azrin.
Thank you so much to BINUS for this opportunity. Because basically I did receive the invitation from one of my colleagues at Universiti Malaysia Pahang that offers me and one of my friends regarding the opportunity to share our lecture with student from BINUS. All right. Thank you so much once again for this opportunity. And I did receive this poster given by Bapak Wikaria. Thank you so much again for BINUS University for creating this wonderful poster so that student will be informed regarding this session. All right. So before I proceed, I would like to share with you some information regarding my faculty. My faculty at Universiti Malaysia Pahang is called as Pusat Sains Matematik. So basically, if you would like to get more information related to our faculty, perhaps you have the ideas on continuing your postgraduate in Malaysia, or maybe you just want to browse through some information related to our center, you can go to psm.ump.edu.my. So basically, when it comes to double integral, I believe before you go into this topic, you have learned about single integration. And normally, when it comes to single integration, before we want to learn something, we would like to understand what is the application, because sometimes when people cannot relate the importance of studying things during their study, they cannot get the ideas what is the importance of learning such knowledge. So if you go to some reference book, or nowadays you can simply Google some information related to integration as a whole, you will find that integration will be useful when we would like to determine the area between curves, we would like to determine the distance, velocity, and acceleration, or we can use integration to determine the volume of the surface or the volume of an object. perhaps you can use integration to determine the average value of a function, or maybe right after this, right after you learned a little bit about double integral, you will see that double integral will be useful when you try to explain about the question which I have shared over here. Something like you can use double integral to determine the mass density function for a lamina. Basically, you can use also double integral to determine area under the curve. And you can also use double integral to determine the mass density function on a lamina, or you can use double integral to solve problem related to joint probability density function, right? So as you can see from here, this is the definition when it comes to double integral. So as you can see from this definition which I get from Bapak Wikarya, so basically the definition for the double integral actually define the double integral over a bounded region R, or for example, actually the double integral of a function in the rectangular region is actually the limit of the Riemann sum. So if you try to look at the keyword Riemann sum is an approximation of a region's area obtained by adding up the areas of multiple simplified slices of the region. I believe that such illustration has been provided by the slide presentation prepared by the Venus to the student, right? So actually that basically it when it comes to the introduction to double integral. Let me share with you. Okay, so basically we use this module when we teach double integral to student. Okay, jika kita lihat untuk subjek matematik di Venus University, the subject's name is actually Advanced Calculus 1. When you go to Universiti Malaysia Pahang, the subject which we discuss problem related to double integral, the subject's name is actually Applied Calculus. So by right, today we would like to take a look on how we can solve problems related to double integral, right? So basically, double integral can be used to determine the volume of the surface, or you can use double integral to determine area under the curve, right? Ataupun you can use double integral to determine the area of the region R, which we will try to explain one by one later. So basically, I will introduce to you what is double integral over rectangular region, double integral over non-rectangular region, double integral in polar coordinates. So basically you have learned some preliminary knowledge before you go to double integral. So as you can see from here, the volume of the surface can be determined by using double integral, which is V is equal to double integral over region R for function fxy dE. So basically, when you try to solve problem related to double integral, you need to have the ideas what is the region R based on the given double integral problem, because the region R will be useful when you try to determine limit with respect to variable x and with respect to variable 1. So as you can see from here, before we try to explain more details when it comes to double integral, we would like to introduce a little bit about partial definite integral. So if you learned about partial derivative, so basically partial derivative is the reverse of the partial derivative which you have learned before you go to this topic. Okay, kita namakan dia sebagai partial definite integral. The reason why we call it as partial definite integral because we can define the limit with respect to that particular integral. So as you can see from here, The reason why we call it as double integral over rectangular region is that when you try to illustrate the region R, it somehow resembles a rectangular shape. Hence, explain why we call it as double integral over rectangular region. And normally, in layman term, when you try to solve problem related to rectangular region, the limit normally will be in the constant value, which is a number instead of a function, which we will go into detail when we try to solve problem related to non-rectangular region. So basically, if this is your integral, the function f x y, you can, when you try to expand your dA, because right now we are talking about the general part. When we explained about double integral, we are talking about double integral over region R with respect to A. So basically, when you try to expand A, you can either have type 1 integral or type 2 integral. Type 1 integral is actually dy dx. Meanwhile, type 2 integral is dx dy. So what I'm currently writing over the note taking apps, I'm talking about this one sebagai type 2 integral. Meanwhile, if you have this kind of setup that consists of this kind of arrangement, dy, yes, this one we call it as type 1 integral. So basically, we have a theorem that explained about, but actually, if you try to solve the problem either by using type 1 or type 2, you will end up with the same answer towards the end. We call it as a Fubini's theorem. This Fubini's theorem consists of this iterated integral, where the first one is in integration either with respect to variable y, or the second one is the integration with respect to variable x. So as I mentioned earlier, since when we try to solve problem related to double integral, you need to have the ability to illustrate your region R. Sometimes the region R can be will be provided based on in terms of limit, or sometimes the information related to region R will be given as an explanation inside the question. So you have to take more, you have to be able to interpret the information if it is somehow is given in the written format, or if the limit is given to you, it will be quite a straightforward question. So as what you can see from this example, the question asks you to determine or to evaluate the following double integral with the information given in this mathematical expression. So as you can see from this example, it is quite straightforward. Sometimes I myself will be asking this type of question during quiz, and normally we will focus more on double integral of a non-rectangular region during test or final. So again, this integration is quite straightforward, as I mentioned to you earlier, since we have introduced about partial definite integral. So if you are previously, if you solve problem related to partial derivative, when you try to find the partial derivative, consider you have more than one variable, you need to differentiate with respect to the variable, and whatever variable that is not related to that particular variable, you will assume it as a constant. So the same thing goes to this reverse partial derivative, which we call it as partial definite integral. So basically, as you can see from this example, if you try to integrate with respect to variable x, and whatever variable that is not related to variable y, you will consider as a constant, and it should behave like a constant. So as you can see from here, from this example, when you try to integrate with respect to variable x when x is from 0 until 1. So you can assume e to the power of y as a constant. So it won't be a part of your integration with respect to variable x. So even though our double integral is actually iterated integral that consists of two integral punya notation. So basically the ideas will remain the same, and whatever techniques you have required to solve problem related to single integral will be also useful when you try to solve the problem when it comes to double integral. So as you can see from here, since e to the power of y is not a part of the integration, so you can focus on integrate the expression with respect to variable y. Since x is a polynomial, so you have to be able to recall how to integrate a polynomial function. So basically, this is rather a simple polynomial function. Therefore, it is as straightforward as x squared over 2, and then you try to evaluate it from 0 until 1. So I think you should be able to get the ideas when it comes to solving problem related to double integral, right? So I believe I have explained about the iterated integrals, and I also explained a little bit about double integral over rectangular region. So basically, when you try to refresh your memories when it comes to double integral of a rectangular region, you can always associate it with the limits, where the limits is written in terms of value instead of a function. And at the same time, when you try to illustrate the region R onto XY plane, so you will end up getting this rectangular shape, hence explain why we call it as double integral of a rectangular region. So anyone, any question that you wish to ask? Because I don't think that I need to spend more time on double integral of a rectangular region, because it is rather straightforward. Any question that you wish to ask before I move forward to the next topic? Okay, again, as you can see from this example, and according to what I have explained earlier, when it comes to double integral, you can use double integral to determine the volume of the surface, and you can also use double integral to determine the area of the region R. So this is the formula which I have written earlier, such as that is the formula to determine volume of the surface. So in this case, you need to know what is your function of xy. You need to find the information normally will be given inside the question, and at the same time, when the question instructed you to determine the area of the region R by using the knowledge of double integral, you need to do some assumption, something like the function of xy is equal to 1. The reason being, the function has been embedded into one of the integral of the double integral. Okay, we will take a look at this question, more of this question right after we move to the next topic. Any question that you wish to ask before I move forward to the next topic? Right, please don't hesitate to unmute your microphone and let me know if you have any questions. So I'm not going to.
Excuse me.
All right. Please.
Hello.
Hi.
Hello.
Hello.
Oh, it's active. Okay. I want to know about the type 2 formula. Does it mean the first and second integral can be are interchangeable, can be repositioned, which is what is the word it can be prioritized, I mean?
All right. Thank you so much for the question. May I know your name?
Garibaldi Britan Abdillah.
Do you have any short name?
Gary or Gary?
Gary. Okay, thank you so much, Gary, for the question. I believe I have mentioned earlier, basically, when it comes to double integral, you can choose to solve the problem either by using type 1 and type 2, but sometimes when we move from one question to another, there will be a situation where it will be much simpler if we choose to solve the problem by using type 1 or type 2. So normally you need to see the type of question given to you, or perhaps from one question to another, the instructor or your lecturer will emphasize inside the question either to solve it by using type 1 or by using type 2. Okay, the reason why we have a theorem that mentioned when you try to solve the problem by using type 1 and type 2, you will end up with the same results, because as mentioned earlier, when you try to solve the problem, when it comes to double integral, you need to have the ability to sketch the region R. So from your region R later, which I will try to focus more later inside double integral of a non-rectangular region, you will see that right after you sketch the region R, you will be able to decide whether it is much simpler to solve it by using type 1 dy dx or by using type 2 dx dy. So sometimes, according to your question earlier, it will be very according to the question given to you. All right, but I will try to show the difference on how we can make use of such information which I have shared earlier in the coming topic, which is over non-rectangular region, because I believe double integral over rectangular region is rather simple. I will try to explain more inside double integral over non-rectangular region. But I appreciate your question, Gary. Thank you so much. Is there any other question student would like to ask? Right, so let's take a look at this example where the question asks you to determine volume of the box that is bounded by the plane z is equal to 4, the planes x is equal to 2, and y is equal to 3 in the first octant. So basically, you need, since we are in this topic that require you to learn about double integral, therefore, in order to solve this problem, you have to make use of the knowledge of double integral over rectangular region. So I believe the question is rather straightforward, and at the same time, you have to take into consideration all the information listed inside the question, such as the question asks you to use double integral to determine the volume of the box. Hence, you have to pay more attention towards the word volume. So in order to determine the volume of the box by using double integral, okay, we have to double integral for function fxy. As mentioned earlier, okay, in order to determine the volume by using double integral, you need to identify what is your function fxy. We know that previously, for function of an independent variable, normally you will write it in this direction, y is equal to fx. When it comes to function depending on two independent variables, you will normally write something like z is equal to fxy. Since this question require you to determine what is your function fxy, and at the same time you get z is equal to 4, you can simply plug into the formula 4. So in this particular case, since we are dealing with this double integral of a rectangular region, and normally the limits will be written in terms of value or a constant value instead of a function, which we will discuss further in double integral of a non-rectangular region. So in this case, you can either choose type 1 or type 2, you will end up getting the same result, dy. Yeah, since right now I'm choosing to solve the problem, or perhaps I can try to solve it by using dx dy. Okay, so I should know that the first integral belongs to variable x, therefore the lower and upper limit is limit correspond towards variable x. In this case, plane is x is equal to 2. Since we are talking about a box, if you can illustrate what a box is, kita boleh illustrate lah. This is Z, this is Y, this is X. So the question asks you to determine the volume of the box, which is bounded by Z is equal to 4, X is equal to 2, and plane Y is equal to 3. And at the same time, limit with respect to variable X. Okay, if we use this if we use this illustration, we should know that this will be our region R. Okay, this is our region R. So our limit must be within that shaded part. So in this case, obviously, X is from 0 until 2 and Y is from 0 until 3. Okay, kenapa saya tahu bahawa ianya berada pada octant yang pertama? The reason is because it has been stated inside the question. We are talking about a box that lies in the first octant. Okay, and then you can try to solve the problem because this is rather simple. Right? Okay, let us discuss about properties of double integral because this will be very useful when we would like to solve problem related to double integral. So basically, whatever properties that you have learned in single integration will be quite similar to properties of double integral. Okay, the first one is talking about when there is a multiplication between double integral and a scalar value. So what should you do when you have this kind of setup? So basically, you can always factor the constant out and then you focus on solving the double integral. And towards the end, you can multiply with the scalar value which you find inside the double integral. Okay, the first one, the second one, I believe that is when you have problem related to what should you do if the function of the integrals somehow consists of two different functions. So you can either you can solve it by solving each function separately. So that that is what the properties tell us for the second and third properties, where the function is somehow is written in terms of addition and subtraction operation simultaneously. Not simultaneously, respectively, right? So eventually, there will be a situation where a region R can be separated into two different regions. So what should you do when you encounter such problem? So it tells you here that, so macam ni, let me illustrate to you. So for example, maybe you have this condition where this is your region R and this region R is separated into two different regions. So when this happens, what should you do? So basically, you can solve it according to these properties, where you can find whether you want to evaluate the double integral, or you want to determine the volume, or you want to find the area under the region R. You can find them separately, right? So the limit for both double integral will be somehow different from one double integral to another double integral. So that's basically what the author tried to explain when it comes to properties of double integral. Right? Is there any question that you wish to ask before we move towards the next interesting topic, which is double integrals of a non-rectangular region and double integral in polar coordinates? Any question you wish to ask? Okay, so I believe there is no question from the student, right? Let us move forward to non-rectangular region. So basically, if you want to understand the term non-rectangular region, so you can expect the region R, which is compulsory for you to sketch, won't look like a rectangular. Instead, it will be different than rectangular region. All right, so hence explain why we name such topic as double integral over non-rectangular region. Okay, for example, when this is your region R, so it will be quite, this is not this is not rectangular region, but there will be steps need to be taken in order to tackle such question. So normally, when you are discussing problem related to double integral of a non-rectangular region, the limits, one of the limits must be in the form of function instead of both of the limits is written in terms of value or constant number. So basically, what we are going to focus in this topic, non-rectangular region, you should know on how to sketch the non-rectangular region of the integration. You need to be able to determine the limit of the double integral, and actually you need to know on how to evaluate the double integral and how to use double integral to determine the volume of a solid or surface, or use double integral of a non-rectangular region to determine the area of the region. And you need to know on how to reverse the order of the integration. So as I mentioned to you earlier, when it comes to double integral, we have type 1 and type 2 integral. Type 1, normally we will associate it with dy dx, and type 2, you will have to associate it with dx dy. So I have take a look at the slide presentation given by Bapak Wikarya. So if you think that my information is rather not into your syllabus, maybe you can take it as knowledge, so that when you try to solve the problem related to double integral, you need to you have an idea as how it looks like when you try to solve it. Okay, all right. So as you, I believe I need to explain based on the example instead of focusing on the definition, because it will be more helpful in that direction. All right. So as you can see from here, you are given with an expression double integral over the region R, and then the function fxy is given as 2x plus y. And obviously, when we are talking about double integral, you are given with dA. dA can be either type 1 dy dx or type 2 dx dy. So as you can see from here, the region R is explained. The region R is described as a triangle bounded by x-axis, y-axis, and a straight line to y plus x is equal to 2. So basically, this region of integration normally won't be given to you. I mean the illustration, because this is the module, we provide this kind of information to the student so that the student will know on how to start with on how to solve the problem. So basically, you are given with this double integral over region R over the function 2x plus y, and then dA. So right now you have to decide whether to solve the problem by using type 1 or type 2. Okay, if we follow the direction inside this module, the author solve the problem by using type 1. Later, we can see that when we want to solve the problem by using type 2, it will end up giving you the same answer towards the end, all right? Okay, so right now, you need to be able to illustrate the region R. Okay, so I'm not sure with the direction of Binus when it comes to this advanced calculus one, whether the illustration will be given to you, but normally in UMP, we will ask the student to illustrate the region R, because we want to know whether they know or not on how to sketch the region R based on the limits given to them or based on the description given in the question. Okay, so right now you will need to know that the region R always lies in two-dimensional coordinate system that consists of y-axis versus x-axis. And then it has been stated inside the question that this region R is bounded by x-axis. So you need to know where is your x-axis. So this is your x-axis and your y-axis. And you are given with with any question, which obviously, even though the question did not state that that equation represents a straight line, that is indeed an equation that represents a straight line. All right. So you can find the x and y intercept. So x intercept is equal to 2 for this particular question. And y intercept is equal to 1. Right? So I will end up getting a straight line over here. And then this is my region R. Okay, so right now we have to decide whether to solve the problem by using type 1 or type 2. Since the question never indicate or never force you to solve it either by using type 1 or type 2, you have to decide. Normally, people will try to solve the problem by using type 1 integral. So what will happen? Type 1 integral dy dx. So it should tells you that the first integral is actually integration with respect to variable y, followed by the second integral, integration with respect to variable x. Okay, normally I will tell the student when you want to determine the limit of the integration for both variables, you need to first decide type 1 or type 2. Since we have decided to solve the problem within type 1, so you should know that the term dy actually represent, okay, when you try to bring out information related to dy actually represent changes in y. Okay, dy represent changes in y. Therefore, this is my way of teaching my student to determine the limit right after you manage to sketch the region R according to the description given to you or based on the limit given in the question. So since we have decided to solve it by using dy dx, which is type 1, dy represent changes in y. So I need to sketch an arrow bottom up direction. So according to this arrow, you will know that what you need to decide your limit with respect to variable y according to this arrow. So according to this this arrow, as you can see from here, it will touch the x-axis. Am I right? Okay. We tengok kat sini, I can touch the y-axis. It will touch this straight line. Am I right? And at the same time, we have to acknowledge the first integral is integration with respect to variable y. Therefore, the limit must be y is equal to what? In this case, what is the best direction? What is the best expression to represent a line that lies on the x-axis? Anyone would like to guess or give your ideas? Semua boleh dengar ke suara saya? Everyone can hear my voice clearly? Okay, kalau lihat di sini, cuba lihat di sini. Dia akan, according to my explanation earlier, when we would like to determine limit with respect to variable y according to the region R which we have sketched earlier, so I need to sketch an arrow bottom up direction which is parallel to y-axis because I would like to demonstrate dy, which is changes in y. So based on this arrow, based on this arrow, and at the same time, since this is our region R, okay, my question is that what is the lower limit with respect to variable y? If you look at this arrow, it will touch this straight line, and this straight line lies on x-axis. And what is the best expression, or what is the best expression ataupun equation that that represent a straight line that lies on x-axis. Anyone would like to give answers or provide some feedback? Hello, semua boleh dengar ke suara saya?
You pointed me?
I'm not pointing you. I'm asking the rest of you. Anyone would like to give a thought on what is the lower limit with respect to variable y when we try to set up our double integral over here? Hello, ada sebarang feedback? Okay, saya nampak ada persamaan bagi kuliah di Malaysia dan kuliah di Indonesia. So pelajarnya tidak mahu unmute the microphone and talk to me. So anyone would like to help me? What is the lower, because this is the only way I can assure the student are able to understand my explanation. Or perhaps I can call Gary once again. Gary? Yeah. Yes.
Could I ask some solution? Could I give some solution to this question?
Yes, please.
Maybe we can use the type 1 integration, because I've seen the solution of this question.
So you don't want to use type 1 to solve the problem?
Yes.
Actually, you can use type 1 to solve the problem. Because as you can see from here, since I have mentioned earlier, in order to determine limit with respect to variable y, I need to sketch this arrow, and this arrow will be able to help me to point out what is the lower limit, what is the upper limit with respect to variable y. Okay, Gary, so basically, when I sketch this kind of arrow, I know that this arrow touched this red curve. Therefore, the best expression or the best equation that represent y x-axis is actually y is equal to 0. Therefore, y is equal to 0 will be the lower limit with respect to variable y, and towards the end, you will see that this arrow will touch the black line, and the black line is represented by the equation 2y plus x is equal to 2. Right? So as you can see from here, since the first integral is integration with respect to variable y, therefore the lower and upper limit must let y as the subject of the expression. So in this case, you have to let y as the subject of the expression. You will get 2y is equal to 2 minus x, and y is equal to 2 minus x over 2. Therefore, the upper limit with respect to variable y is actually 2 minus x over 2. Okay, and then right after that, when you try to determine limit with respect to variable x, you need to observe this region R is from which value of x-axis until which value of x. So in this case, in order to cover the whole region R, x is from 0 until x is equal to 2. Therefore, this is how you write down the limit with respect to variable x. Okay. Mungkin ada masih yang tidak faham lagi. So let me try to solve the same problem by using type 2. Okay. I sketch this warna ungu ni okay, because right now I would like to solve the problem by using type 2 integral, which is dx dy. Hence explain why I sketch an arrow on this region R left to right. So that is the only way in order to make this, in order to solve this problem. It cannot be from right to left, but it must be from left to right, right? So in this case, this is actually the first integral is integration with respect to variable x. Therefore, the limit must belong to x equal to what value? Okay. And anyone would like to give me what is the lower limit with respect to variable y? X. According to this violet arrow, right? The violet arrow will touch which curve first? Dia akan menyentuh pada permukaan garisan apa terlebih dahulu according to your raw observation. Anyone would like to explain? Zero. Obviously, it will touch the y-axis, am I right? So the best expression to represent whatever that lies on y-axis is x is equal to 0. And then what is your upper limit with respect to variable y? Right after it touch the y-axis, it will touch which line?
2/2y.
2 minus 2y. That is...
Yeah, 2 minus y, yeah.
Yes, 2 minus 2y. 2 minus 2y will be the upper limit with respect to variable x. And then when you try to determine limit with respect to variable y, you need to observe the region R in order to cover, because you have covered the x part. So right now you have to take more, you have to take a look at y axis. In order to cover this region R, y should be from which value to which value? Y is from which value to which value?
0 to 1.
Yes, that's correct. 0 to 1. Okay. Later, right after we end this session, you can try to solve the problem. You will see that you will end up with the same answers. Okay, even though it will give you the same answer, but as you can see from here, the limit will vary according to how you solve the problem, either by using type 1 or type 2. Even though it will give you the same answer, but as you can see from here, it will give you different limits when you take dy dx. When you try to solve it by using dy dx type 1, you will end up having that kind of limits. When you try to solve the problem by using type 2 integrals, type 2 approach, you will see that it will give you different limit, but towards the end, it will give you the same answer, because we do have a theorem, Fubini's theorem, that mentioned to us, type 1 or type 2, you will end up with the same answer. So that is how you solve the problem. Okay, again, yeah, you can use double integral to determine volume of the surface, and you can use double integral to determine the area of the region R. So you have to pay more attention towards the question given to you. As you can see from here, the question asks you to determine the area of the region enclosed by the parabolas y is equal to x squared and y squared is equal to x. So again, yeah, I'm not sure what is the direction in Venus when it comes to advanced calculus 1, but in Universiti Malaysia Pahang, we require the student to sketch the region R according to the description given to you. Okay, so I'm going to show you that that way of solving the problem. So in this case, you need to know on how to sketch these two curves, which represent a parabola, and you have to sketch these two parabolas on the same coordinate plane, in the same xy plane. So in this case, you have y is equal to x squared and x is equal to y squared. All right. So we have to illustrate or sketch the region R first. This is y, this is x, and this is y is equal to x squared, and this is y is equal to x is equal to y squared. Right. So the question asks you to determine the area of the region R, which has been explained as area enclosed by these two curves. So enclosed maksudnya it somehow must include these two curves. So this is the only way that explained about enclosed between two curves. When this happens, you would like to determine the area of the region R. So again, this is your region R, and when we want to solve problem related to determining the area of the region R by using the knowledge of double integral, we have to make some assumption, such as fxy is equal to 1. So you will see later, if you would like to solve the problem by using single integration, you will see that this function fxy has been embedded into one of the integral inside this double integral. So that's why you have to assume fxy is equal to 1. So in this case, since you have made that some assumption, this is the formula to determine the area of the region R. So again, you have to decide whether to solve the problem by using type 1 or type 2. Since I don't see that there is a problem when we are dealing with this kind of region R, so you can choose to solve it by using type 1 or type 2. dy. Yes. Later, I will show to you on how to solve it by using type 2. Okay, so right now, what should you do? Again, you need to sketch an arrow bottom-up direction parallel to y-axis, which indicate changes in y. So as you can see from here, this arrow will touch the darker green curve. And the darker green curve is given by that expression y is equal to x squared. And then you will be touching the light green curve, which is represented by that expression x is equal to y squared. Therefore, the first integral is integration with respect to variable y, and the limit is y is equal to something. So, according to your observation and your understanding, do you mind share with me what is the lower limit with respect to variable y?
Is it x squared?
Yes, that's very good. Y is equal to x squared will be the lower limit with respect to variable y. And then what is the upper limit with respect to variable y? The red arrow will touch the light green curve. And you have to put into consideration the y should be the subject of the expression. Since right now, in order to become the subject of the expression, y must be to the power of 1. Since right now y is to the power of 2, you have to get rid of that square. So you will know that y is equal to plus minus z(x). Okay, you have learned a little bit about parabola previously. So this is the region where y is equal to positive z(x), and this is the region where y is equal to negative z(x). So my question to you, what is your upper limit with respect to variable y?
Square root of x.
Yes, positive square root of x will be the upper limit with respect to variable y. So right now, you need to determine lower and upper limit with respect to variable x. So that can be found. As you can see from here, these two curves overlap and intersect at a point. So obviously, in order to determine the intersection point between these two curves, you have to solve these two curves simultaneously. So in this case, or you can use a simple substitution. Okay, since y is equal to x squared, subs into x equal to y squared. Okay, so I will get x is equal to y x squared squared. X is equal to x to the power of 4. X to the power of 4 minus x equal to 0. You factor it, you will get x cubed minus 1 equal to 0. X is equal to 0. And x cubed minus 1 equal to 0. X cubed equal to 1. X is equal to 1. So you will see that they will intersect at x equal to 0 and x equal to 1. So what is the lower and upper limit with respect to variable x?
Zero to 1.
Yes, that is how you solve that is how you determine lower and upper limit with respect to variable x. I have 1 more hour, so I don't think that I have time to explain on solving the problem. But you can always try to solve the question from time to time. So if you think that you want this kind of question, perhaps right after we end the session, I can send this information to Bapak Wikarya so that Bapak Wikarya can send the file to each and every one of you. All right. So previously we tried to solve the problem by using type 1. Now,
Sir, may
yes,
sorry to interrupt. Can
Yes,
I
yes.
ask question for the previous question?
Yes, please.
Why from the x? Why it must be 1, not? Sorry, I speak Indonesian. Akar
Okay.
y,
Nah,
akar y.
teruskan.
Why? Kenapa di x? Kenapa tidak akar y tetapi 1?
This one fxy, why fxy is equal to 1? This is your
Bukan, no, di AR integral di integralnya.
di sini.
Kenapa harus 1 bukan akar y?
What is akar y?
Ada di kurva yang Bapak gambar. X sama dengan y kuadrat. Ini.
Kenapa di kuadran yang pertama? Itu kesoalannya?
Itu kenapa 1 bukan akar y? Jadi 1.
Oh, okay. I think I understand the question. Kenapa bukan I still cannot hear your akar y. I cannot understand that word. So but basically,
Okay.
all right. So basically, when you try to determine limit, I think you have a problem with how to determine limit with respect to variable x. So you will see that in order to solve the problem as what I have mentioned earlier, the first integral, the limit for the first integral, normally you need to sketch an arrow. Okay, that arrow will be helpful because that is how we solve the problem. Because the first integral we need to sketch an arrow so that we get because right now we would like to cover the region R. So in order to cover the region R, when it comes to non-rectangular region, we sketch the arrow which illustrate the word dy that represent changes in term of y. So changes in term of y, so that is how I sketch an arrow which is parallel to y-axis as if it demonstrates changes in y. And when I try to determine limit with respect to variable x, I need to observe. I don't want to sketch an arrow because if I sketch an arrow, it won't bring me to anywhere. So basically, in order to cover the region R, we have covered in y direction by using that red arrow. But when we try to cover region R, we have to observe the region R. The region R along x-axis, it covers from which value, which coordinate x until which coordinate x. So in this case, the reason why I try to solve these two equations simultaneously by using simple substitution in order to determine they are intersecting at which point. So in this case, I believe I don't have to determine the point. I just need to know the x coordinate. So in this case, x is equal to 0 until x is equal to 1 will help me to cover the whole region R. Because right now, the idea is that we need to cover the whole region R. So that is our intention, to cover the whole region R. From Y perspective, we have covered through that red arrow. From the perspective of x-axis, we need to observe the region R is from which x coordinate to which x coordinate. I hope saya sudah menjawab soalan.
Yes, okay, I understand.
All right. So let's try to solve the same problem, but this time around we try to solve it by using type 2, which is dx dy. Okay, even though they will give you the same answer, but if you do it in this direction, it will be very helpful to you in the future. Sometimes there will be a situation where I will try to demonstrate a question where you will see that we need to apply the properties which I have explained earlier in the previous topic. So sekarang ni saya akan melukis satu. Yang ni saya tahu bahawa this is x, this is y is equal to x squared. Okay, that's I use this violet color that represent x equal to y squared. Okay, if this is my region R, and this is the region of the integration, region R. Okay, I need to sketch an arrow because I have decided to solve the problem by using the dx dy. So right now, I need to set up my double integral. AR fxy is equal to 1. Always remember dx dy. So I have sketched an arrow from left to right, which demonstrate changes in x. Therefore, I need to acknowledge that the first integral, x must be the lower and upper. We need to determine lower and upper limit of the first integral with respect to x. So x is equal to something, and the second integral, y is equal to something. So when you have this kind of question, okay, according to this arrow, this red arrow will touch which curve first? Curve yang berwarna apa dia? This red arrow, garisan berwarna merah telah menyentuh permukaan apa terlebih dahulu, dan permukaan tersebut diwakilkan oleh persamaan apa?
X equal to y squared.
Yeah, so therefore x is equal to y squared will be the lower limit with respect to variable x, and right after that it will touch which curve? Curve yang berwarna apa?
The green one.
The green one. So as you can see from here, right now we are talking about we would like to determine lower and upper limit with respect to variable x. Therefore, x must be the subject of the expression. But this time around, same like what we did earlier. Previously, y is to the power of 2, and you need to acknowledge when we not want to determine upper limit with respect to variable x, x must be to the power of 1. So what should we do? We have to get rid of x to the power of 2 on the right hand side. We put in the left hand side. It's not as simple as putting square to the left hand side, but the inverse process will be set kan, x is equal to set y plus minus. So this is the region where x is equal to positive y, and this is the region where x is equal to negative set y. So my question to you, what is your upper limit with respect to variable y? With respect to variable x? X is equal to?
Positive square root y.
Yes, positive square root y. So this is how you determine limit with respect to variable x. And then you need to observe this region R along y-axis. Previously, we have solved that x is equal to 0 and they intersect at coordinate x is equal to 0 and x is equal to 1. So if here is x is equal to 0, therefore y obviously equal to 0. If this is x is equal to 1, you substitute back into the expression such as x is equal to y squared, then juga y is equal to x squared. So when x is equal to 1, y is equal to 1 squared, which is 1. So the value here adalah 1. So in order to cover the region R, y coordinate must be from which value to which value. And what is your lower and upper limit with respect to variable y? Y is equal to
0 to 1.
yes, this is how you determine limit with respect to variable y. Right? Any other question? So I hope you will be able to solve the problem on your own. Okay. Right now we have this question where this particular question asking you to determine the volume of a tetrahedral, which is plane that is bounded with all three coordinate plane, xy plane, xz plane, and yz plane. Hence, you end up with a plane that lies heavily in the first octant. So that is what we meant by the word tetrahedral. Right? Sebab tu dah dinyatakan di situ, tetrahedral bounded by that particular expression. Alright, so right now what should we do? Right now, when we try to solve this problem, you need to be able to sketch the tetrahedral according to the question. Lucky for us, the tetrahedral has been drawn by the authors of this book. So I will end up copy whatever I get inside here. Di sini nilainya 2. So this is your surface. The question asks you to determine the volume of the surface. So the volume of the surface can be solved by using this formula of double integral fxy d E over region R. So again, you have to decide whether to solve the problem by using type 1 or type 2. So I think let us try to solve the problem by using type 2. So when that happens, you need to identify what is your fxy. So again, z is equal to fxy. By letting z as the subject of the expression, you will get 2 minus x minus 2y as the expression where you let z as the subject of the expression. So this is your fxy. Right? So right now, I try to set up my double integral first. Okay, so right now, you have, okay, so you can decide the lower and upper limit with respect to variable x and y by looking at this solid or this surface, but I strongly suggest you, if you think that you cannot sketch an arrow properly by looking at this solid G, you try to transform your surface from 3-dimensional coordinate system onto xy plane in 2-dimensional coordinate system by using all the information that you can get from this solid. So basically, you need to transform it to two-dimensional coordinate system, y versus x. X is equal to 2 and y is equal to 1. So this will be your region of integration. All right. Again, we will do whatever we have learned earlier. And what is the equation that best represents this straight line? So this is the equation can be found according to the expression that represent the surface. So when we project our surface onto xy plane in 2-dimensional coordinate system, therefore on xy plane there is no variable z. Therefore you can always assume z is equal to 0. Hence x plus 2y equal to 2 actually an equation that represents a straight line. Or if you cannot relate it with that kind of information, you can always form the equation since you already have the information related to x-intercept and y-intercept of this particular straight line, you will end up getting the same answer, x plus 2y is equal to 2 as the equation that best represent the straight line. So again, you already have your double integral, you already sketch your region of integration. So you have to set up your double integral. Volume is equal to double integral, and this is your fxy, which is 2 minus x minus 2y dy dx. If we decided to solve the problem by using type 1 integral. So again, sketch an arrow in that direction. So it will touch the x-axis, and y is equal to 0 is the equation that represents x-axis. And right after that, it will touch the curve. You will end up getting the same answer, which is 2 minus x over 2 as the upper limit with respect to variable y. So again, when you try to determine limit with respect to variable x, you need to observe the region R. In order to cover the region R, x must be from x is equal to 0 until x is equal to 2. Any question that you wish to ask?
What's going on? Why it stops?
No, I'm asking you, do you have any question? I'm not stopping, I'm asking, I pause for a while so that I can ask the student. Anyone would like to ask a question? All right, so if I don't get any question, I will try to proceed with this example. Okay, the question asks you to determine, find the volume of the solid that lies under the parabola z is equal to x squared plus y squared and above the region R in the xy plane bounded by the line y is equal to 2x and the parabola y is equal to x squared. So basically, you have been given with the information related to what is the equation that represent the surface and what is the region R. So basically, dia bercerita tentang apa tu, you are given with a parabola, right? And the region R is explained as above the region R in the xy plane bounded by the line. Okay, dia kata a region R consists of two curves, where the first curve is actually a straight line y is equal to 2x, and the other curve is as y is equal to x squared. So when that happens, you can move straight away to sketch your region R according to the description given to you. So right now you have a parabola y is equal to x squared and a straight line y is equal to 2x. Okay, so this will be your region R, because region R is always enclosed by these two curves. Okay, therefore, you can start to set up your double integral. So when you set up your double integral, the question asks you to determine the volume. So volume is equal to double integral for function fxy. Obviously, fxy is equal to x squared plus y squared dy dx if we decided to solve the problem by using type 1 integral. Again, sketch an arrow bottom up on the region R. So according to your understanding, what is your lower limit with respect to variable y?
X squared.
Y is equal to x squared will be the lower limit with respect to variable y, and the upper limit is y is equal to what?
2x.
Yes, that's correct. Right now, what should you do? You need to determine the limits with respect to variable x, and since we still cannot figure out the intersection point between these two curves, so you have to solve these two curves simultaneously so that you will get the intersection point or at least x coordinate between these two curves. So in this case, you need to solve it. Therefore, you will get y is equal to 2x, y is equal to x squared is equal to 2x, x squared minus 2x equal to 0, x minus 2 equal to 0. Therefore, it will intersect at x is equal to 0 and at x is equal to 2. Therefore, your x is from 0 until 2. So this is how you solve the problem. So what will happen if you decided to solve the problem by using type 1 integral, type 2 integral? X is from which value? It will touch which curve first? Dia akan menyentuh permukaan apa terlebih dahulu?
Y over 2.
Yes, that's correct. Y over 2 will be the lower limit with respect to variable x. How about the next one? X is equal to what?
Positive square root y.
Yes, that's correct. Positive set y. And again, before this, we managed to determine the x coordinate between these two of x coordinate that represent the intersection between these two curves. So when x is equal to 0, y obviously 0. When x is equal to 2, y is equal to 4. Therefore, y is from 0 until
4.
0 until 4. So that is how you solve this problem. Right? So I hope you all learned something about double integral of a non-rectangular region. According to the document given by Bapak Wikarya, so we need to also cover about how to determine reverse the order of integration. So basically, the intention of this particular question normally, we will ask you whether you are able to reverse the order of the integration from type 1 to type 2 or type 2 to type 1. Okay. I believe the question will be straightforward. The question will ask you to express the order of the integration as express the integral as an equivalent integral with the order of the integration reverse. All right. So basically, you must know that the region R can be found by the illustration given by the lecturer or the description given in the first one. The region R can be obtained through the illustration given in the question. The second one, you can sketch your region R based on the description given in the question, or like this, you have to sketch your region R based on the limit given to you. Okay, this is rather new compared to whatever we have learned earlier. Okay, what should we do? Okay, you have to sketch your region R, because by the region R will be helpful when you try to reverse the order of integration for this particular case from type 2 to type 1. Okay, that is the intention of this question. The question never asks you to solve it. For this particular question, the author or the lecturer asks you to reverse the order of the integration. And at the same time, your function fxy is not given to you, so you cannot solve the problem. Just we want to make sure whether you know or not on how to reverse the order of the integration. So this is why, always remember, your region of integration R is always lies on XY plane in two-dimensional coordinate system. Okay, so right now we have to acknowledge we are given with type 2 integral. So kalau type 2 integral, I need to sketch an arrow which will be parallel to X axis and at the same time is moving from left to right direction. Okay, so according to this arrow, dia akan berjumpa apa terlebih dahulu? According to this arrow, it will meet which curve first? Dia akan jumpa apa tu?
Y square.
Yes, it will meet x is equal to y squared. So if you know whatever you have learned previously during your about curve in two-dimensional coordinate system, x is equal to x is equal to y squared will always give you a parabola in C shape, right? Since x is the subject of the expression, therefore you will end up with this curve, a parabola, C shape. And then it will meet which curve?
Y.
X is equal to y. X is equal to y will give you a straight line. And then what's next? What is the lower and upper limit with respect to variable y? If this is x is equal to y, and if this is x is equal to y squared, it should tells you that the y is from 0, then from 1. So this is your region R. Okay, right after you manage to sketch your region R based on the limit given in the question, then you can start set up your double integral. But this time around, it is actually an integration double integral with respect to type 1, type 1. So type 1, first one, type 1 apa? dy dx. So I need to sketch an arrow, and this arrow must be parallel to y-axis, bottom up direction. So according to your understanding, this orange arrow will touch which curve first?
Y equal to x.
Y is equal to?
X.
Yes. And then the upper limit, it will touch which curve? To be careful, y must be to the power of 1. Therefore, for this particular case, y is, the upper limit is actually?
Positive square root of x.
Yeah, that's correct. Okay, when y is equal to 1, when y is equal to 1, x, you substitute into one of the expression that represent these two curves. X is equal to 1. Therefore, x is from x is from x is from apa di sini?
From 0.
Until
1.
yes, brilliant. Okay, this is how you solve the problem. Right? Is there any question that you wish to ask before we move forward to other question? Any question? Ada sebarang soalan that you wish to ask before we move forward to the last topic for today's session? Ada sebarang soalan yang saya boleh jawab? Alright, tidak ada. Okay, so let's move to double integral in polar coordinates. Alright. So when we try to solve problems related to double integral, okay, since this is the last topic under subject double integrals, okay. Before this, you have learned about rectangular coordinates. You know already about few curve in few type of curve in two-dimensional coordinate system. We have a straight line, we have a hyperbola, we have a parabola. What else? We have ellipse, we have circle. What else? I think that's all. And you have learned about few type of curve in polar coordinate. You have families of circle, you have families of cardioid, you have families of limacons, you have families of rose curve. So basically, the reason why we have this double integral of polar coordinate, because sometimes the region R, if you insist on solving the problem later on, that belongs to families, few type of curve that lies in polar coordinates such as families of circle. If you insist on solving the problem by using rectangular coordinate, you will find that the limit will be quite complicated at point if you don't have enough motivation. You won't end up you won't be able to solve the problem completely. Okay, and at the same time, the reason why we want to introduce you with double integral of a polar coordinate system is sometimes if you are dealing with polar curve inside, when you are dealing with polar curve, it is best for you to solve the double integral by using polar coordinate system, right? Because the limits, when you try to set up your double integral, you will end up with a simpler unit other than difficult figure or difficult limits, which at some point you won't be able to solve it. Okay, if you look at this expression, I believe if you read the Bapak Wikarya slide presentation, you will see that you should be able to recall what is double integral in rectangular coordinate system. It is given as V is equal to double integral over region R, a function fxy, dE. But when you try to solve it using double integral in rectangular coordinate system, you should be able to transform everything from xy in rectangular coordinate system to r theta in polar coordinate system. I believe you have learned about polar coordinate system previously. Polar coordinate system consists of element r, which is a directed distance, and also variable theta, which is a directed angle. All right, so right now what should we do? We have to transform everything. Double integral function, instead of fxy, change to fr theta. And dA, when you try to expand dA, you will end up getting r dr d theta. So eventually you can either have r dr d theta or r d theta dr or d theta r dr. It's up to you. Okay, because it won't affect your limit in either position of r and theta. Here, I'm talking about here, because previously it is very important for us to decide either to use type 1 or type 2, because the limit won't be equal when you solve the problem in type 1 or type 2. But we can assure you your final answer will be equal, because we have a theorem that mentioned to us that type 1 or type 2 will lead to the same answer. Okay, so as you can see from here, the first integral, I'm going to focus on this kind of setup only, RBRD theta, where the first integral, you have to determine what is the integral with respect to variable theta. This is how you transform everything from xy to r theta in polar coordinate system. Okay. After this, I will explain about. Okay, so this is what you can do again. Yeah, when you try to solve the problem, when it comes to determine the area of the region R by using the knowledge of double integral, you have to make an assumption such as your FR theta is equal to 1. So this is a compulsory assumption which you need to use if you would like to determine the area of the region R by using the knowledge of double integral. As I mentioned earlier, FR theta somehow has been embedded into one of the integral of this double integral. Okay, I think this is rather a very simple example. So let's try to, if I can get a feedback, do you learn about Limakon or cardioid or rose curve during your polar coordinates topic? Okay, can I get a feedback? Hello? Boleh saya dapat feedback masa belajar topik yang melibatkan polar coordinates, have you been introduced with Bapak Wikarya about polar curve that looks like Limakon, cardioid, families of circle or family of rose curve? Can I get a feedback regarding that question?
Yeah, I think we have learned it.
You have learned those type of polar curve, right?
Yes, I have learned it from Pak Wikarya.
All right. Thank you so much for the response. Right. So basically, I can explain a little bit about this polar double integral. All right. Okay. This question is rather straightforward, where you are dealing with a problem that asks you to determine the area of the polar curve, where you have a polar curve in the polar coordinate system. So as you can see from here, the question asks you to determine the region enclosed by the cardioid R is equal to 1 minus cos theta. So you should be able to get the ideas 1 minus cos theta will give you what type of curve. Walaupun telah dinyatakan di situ R is equal to 1 minus cosine theta. So let's try to sketch it. So make it as a habit to always sketch the region R, even though sometimes since you are rather new to this double integral, it is very helpful if you are able to sketch the region R according to the description given to you. Okay, or else, because some questions require you to solve it by sketching the graph, at least in my institution. All right. I believe this is 1 is equal to 1 minus cosine theta. I believe this is 1 minus cosine theta. But if I did mistake, let me know. I believe this is the right curve represented by that expression. Sini 1, dan sini 2. Alright. So right now, we set up our double integral. The question asks me to determine the area. Therefore, we have to assume FR theta is equal to 1. And area of the region R is given by double integral R dr d theta. That one come by default because that is what we learned when we expand dA, we will get r dr d theta. Therefore, the first integral is integration with respect to variable r. So when you have that particular question, again, yeah, you need to recall back how you measure your directed distance r. Directed distance r is always starting from the pole up to that curve. This is how you measure your directed distance. Therefore, directed distance r, therefore r is from 0, and then it will touch this curve, and this curve is represented by that function 1 minus cosine theta. Okay, again, in order to determine limit with respect to variable r, you have to be able to recall the way you measure your r. R is always measured from the pole up to that curve. In this case, r is equal to 0 until the curve 1 minus cosine theta will be the limit with respect to variable r. And at the same time, the question never put any restriction in this question. They ask you as if to determine the area of the entire cardioid. Since this entire cardioid, or since this cardioid lies in all 4 quadrants, therefore theta is from 0 until 2 pi. So this is how you solve the problem. Okay, this question is very complicated, as if ya, when you try to solve the problem, you nampak dia seperti kelihatannya seperti begitu simple, tetapi it require you to apply some technique to solve it. Okay, if previously I don't show you on how to solve the problem, but I'll give you some insight on how to solve this problem. So as you can see from here, you are given with this kind of setup for double integral. So what should you do? You have to integrate with respect to r, and whatever variable that is not related to r, you have to assume it as a constant, and you will treat it as a constant. So in this case, I will focus on integrating the first integral with respect to variable r. I will get r squared over 2, and r is from 0 until 1 minus cosine 2. So in this case, I will get 1 over 2, 1 minus cosine theta squared. Then I need to expand it, or else I won't be able to move forward. So in this case, I will get 1 over 2, and then I will get 1 minus 2 cosine theta plus cosine theta, cosine squared theta. Okay, and then you try to integrate from from theta is equal to 0 until 2 pi d theta. Now what should you do in here? As you can see, right after you expand 1 minus cosine theta squared, you will see that, as you can see from, you can see that when you expand it correctly, you will get 3 terms. The first term is 1, the second term is negative 2 cosine theta, and the third term is cosine squared theta. As you can see from here, there should be no problem when you try to find the integration of the first 2 terms, because it is quite straightforward. But the problem lies in the third term, because it is written in terms of cosine squared theta. But at the same time, there is no product when you try to find it directly, such as when you try to integrate cosine squared theta directly, you won't be able to solve it. So you have to do some modification, or you have to be creative in order to solve the problem by using the identity. Okay, for the third term, we know that cosine 2 theta is equal to 1, is equal to cosine squared theta plus 1, or minus 1. Okay, cosine squared theta is equal to cosine 2 theta plus 1 over 2. So you substitute into the third term. So you get 1 minus 2 cosine theta plus cosine 2 theta plus 1 over 2. Integrate theta from 0 until 2 pi d theta. Okay, you can simplify it further. 1 plus 1 over 2, 3 over 2, minus 2 cosine theta plus cosine 2 theta over 2. Integrate from theta is equal to 0 until 2 pi d theta. 1 over 2, don't forget. So I leave it for you to discover the rest of the solution on your own. So sometimes when you are dealing with problem that involve with trigonometric, so if you think that you cannot find the product of direct integration directly, so you have to be able to be creative in order to make sure you are able to deduce the complexity of the term into some term which you can find the product of direct integration easily. Okay, let's take a look at this question where you are given with this kind of arrangement or this kind of polar curve that consists of these two circles given by that expression, r is equal to sine theta, r is equal to cosine theta. So basically, you need to sketch these two curves on the same polar coordinate system because we are talking about common region enclosed by these two curves. So I will get this one, obviously r is equal to sine theta. And this is r is equal to cosine theta. Okay, this is your region of integration. All right, so what should we do next? Okay, as you can see from these two curves, okay, since r is equal to sine theta, okay, r is equal to sine theta is symmetric at y-axis, r is equal to cosine theta symmetric at x-axis. Okay, you can safely assume that this common region can be solved in this direction. Okay, let us try to determine the angle intersection between these two curves. Okay, sine theta is equal to cosine theta, therefore tangent theta is equal to 1, theta is equal to pi over 4. This is the information that we know from these two curves. So it will intersect at theta is equal to pi over 4. So right now, when we want to use double integral to determine the area, of the region R, this is the double integral setup. Double integral, we assume fr theta is equal to 1, and then the rest of the integrand is r dr d theta. So right now we have to be able to recall how to determine lower and upper limit with respect to variable r. It always depends on how you measure your r. Okay, r is always measured from the pole and then it will touch the curve. Okay, earlier I said that r is equal to sine theta is symmetric about y-axis, r is equal to cosine theta is symmetric about x-axis. You will see that, you tengok kat sini balik. Okay, this is our region of integration. What should we do next? Okay, since both of these circle is symmetric about region of is symmetric about x and y axis respectively, therefore I can use one curve. Okay, saya boleh kira, ini yang contoh yang kita dah buat tadi. This is what I'm trying to demonstrate, the properties, the last properties of double integral earlier, where the region can be separated into two, kan? So kalau you nampak kat sini, I can have R1. In this direction, I will have R2. Okay. Therefore, I can assume area of the whole region R is equal to 2 times area of region 1, or is equal to 2 times area of region 2, or area of region 1 tambah dengan area of region 2. Okay, if this is my choice to solve the problem, okay, kalau saya nak gunakan R1, right? So I know that I will get R is equal to 0, and then I will touch the curve. And the curve is represented by sine theta. Okay, how about the theta? Theta itself. Theta, as you can see from this green curve, okay, the green curve, it always start from the first quadrant. Therefore, theta is equal to 0, and then it will stop at theta is equal to pi over 4. Okay, this is my way of answer it if I decided to solve it by using this kind of expression, such as 2 times area of region R. So what will happen if I decided to solve the problem by using 2 times area of region 2? This one region 1, this one region R2. Okay, if that happen, I will have R dr d theta. R is from 0, and then I will touch the blue curve. The blue curve is given by cosine theta. Cosine theta. And then the theta is from, as you can see from here, this curve, this blue curve, it also covers the whole region. It covers the, okay, let me rephrase my word. This blue curve, it starts at theta is equal to pi over 4, and then it will end at the y-axis. And y-axis represent pi over 2 because it occupies the first quadrant, right? So the first quadrant ranging from 0 until pi over 2. But when we are talking about this blue curve is from theta is equal to pi over 4, which is the intersection angle between these two curves, and then it will end at theta is equal to pi over 2. So you will see that when you try to solve the problem, either by using this 3 setup, you will end up with the same answer. So how about A area 1 plus A area 2? So you will end up having theta, not theta, R is equal to 0 until sine theta. Theta is equal to 0 until pi over 4. R dr d theta plus double integral R is equal to 0 cosine theta. Theta is equal to pi over 4 until pi over 2. R dr d theta. So this is how you solve the problem. Even though it looks like very simple, we are talking about the region between the common region enclosed by these two circles, but you have to take into consideration we are talking about two curves that is symmetric about x-axis and y-axis respectively, and then you can use either these 3 kind of setup in order to solve the problem. If you don't trust me, you try to solve the problem, you will end up with the same answer.
Dr. Azrin,
Yes, saya.
apologies. Yeah, apologies that the time for the seminar has been finished. So yeah,
Okay. Yeah, eventually.
a kind reminder. Thank you.
Okay. Let me wrap the session because I believe I have time until 4:30. Am I right?
Pawitaria, I think the information is up to 3, is it?
Sampai jam 3, Pak Wi. Pak Wi, sampai jam berapa, Pak Wi?
4:30.
Masih di mute, Pak Wi Karya?
Oh, 2:30 until. Oh, okay. I think 90 minutes, yeah.
Yeah,
Okay.
apologies for that.
Alright. Thank you so much for the reminder, Bapak Wikarya. I have a few more examples, which I believe is quite important. But perhaps we are running out of time. Maybe I can give my handwritten notes to your students so that maybe they can try to read the notes from time to time. Right? So sorry from my end. Bapak Wikarya, suaranya tidak kedengaran.
Terima kasih banyak pada Bapak Muhammad Azari dari Departemen Matematik Universiti Malaysia Pahang. Kami atas nama Nusantara mengucapkan banyak terima kasih atas pemberian kuliah ini sehingga dapat menambah wawasan yang luas bagi para mahasiswa kami. Sekali lagi kami mengucapkan banyak terima kasih. Thank you very much, Mr. Dr. Muhammad Azari.
Okay. Pak Wikarya, probably if students would like to answer to give questions, probably we can answer one or two questions. Is there any questions from the students?
Maksudnya pertanyaan dari
Iya,
siswanya.
dari mahasiswa, iya.
Sebenarnya tadi setiap bagian oleh
Ada ya, sudah ada ya.
sudah dijawab. Jadi ada yang
Iya.
jawab, mengikuti terus gitu. Kalau saya amati tadi, ya.
Baik, iya. Tadi it's a very live discussion. So apologies, Dr. Azrin, if there is misinformation about the timing. Apologies for that. Okay. So I think to wrap up the session, it will be nice if we can have like a photo session. So I would like to kindly invite the students to open their camera for a while, so we can capture your best smile. Yeah. So students, please kindly turn on your camera for a while, if it's possible, so we can capture just a short photo session. Okay, so I will take the photo. Please give your best smile. 1, 2, 3. Okay, thank you very much. So again, thank you very much, Dr. Azrin, for your time and also for your knowledge sharing. Definitely, it has been a very insightful session for our students. They got a lot of examples. So hopefully they can understand better about the theories and the formula as well. So thank you very much again and have a good day ahead. Bye.
Okay, you too. Salam Lebaran.
Yeah. Minal Aidin wal Faizin.
Alright, terima kasih. Jumpa lagi Bapak Wikarya. Thank you so much everyone. If you have any question, you can ask Bapak Wikarya, and I'm more than happy to help from time to time. Thank you so much everyone. Bye.
Thank you. Bye. Students, please don't forget to fill in the attendance thing. Thank you.
Will I quit because I'm already filled the attendance form?
Yeah, for those of you who have filled in the attendance form, you can leave the session. Thank you.
Oke, terima kasih ya Ibu.
Halo, saudari dari Bali. Bentar. Dari jurusan apa ya?
Kenapa Pak Wi?
Sebenarnya kan tadi kelas saya kemudian Pak Samsu Arifin mata kuliahnya mirip saya cuma nggak pakai 1-2, jadi diundang juga mahasiswanya jadi.
Oh
Jadi
gitu.
jumlahnya tadi mencapai 94 total ini.
Oh, nanti untuk daftar mahasiswanya bisa dikirimkan Pak. Jadi untuk mereka kan akan mengisi form ini ya. Datanya kalau Bapak butuhkan bisa nanti dikirimkan oleh Ajeng.
Oh gitu.
Yang mengisi absennya ini siapa saja gitu. Nanti bisa dikirimkan Pak Wi.
Terima kasih Ibu Santi.
Ya, thank you banget ya Pak Wi.
Ya, terima kasih.
Ya, saya Pak Wi.
Itu Bu, sama
Ya
Bu
Pak.
Ajeng ini mau minta apa videonya ke apa?
Oh iya, videonya nanti kita dapatkan linknya dulu Pak. Nanti akan di-share gitu.
Mau share juga ke mahasiswa gitu.
Iya, baik. Thank you
Terima
Pak
kasih
Wi.
Bu Santi. Selamat sore.
Ya, sore. So Ajeng probably we can end the session within the next 1 minute. Students,
Okay.
jangan lupa diisi ya. Sebentar lagi akan kita end sesinya. Terima kasih.
Okay, thank you everyone. I will end the meeting. See you.
Thank you, Jang. Bye.